So, of course, there's a major shift happening in IT today. For the past 6, 7 years, almost 10 years, depending on when the virtualization wave hit your data center, we've been pretty much dealing with a single vendor, and that's vSphere, VMware for vSphere, in terms of our infrastructure, at least on the compute side. Now, we might run Cisco servers or HP servers or Dell servers or whatever, but pretty much we've been running VMware on top of them for the past 6, 7 years, almost 10 years. And that we consider that a private data center. It's not a private cloud, though, and we'll get into that in a minute. But so we've been dealing with one vendor. Our applications we've tooled for deployment onto that single platform for the most part. Now, companies are seeing an explosion of options in terms of deployments. Of course, we have vSphere, and vSphere is still a major part of IT, enterprise IT data centers. But now we've got things like Windows Azure Pack, which is looking more and more attractive, or OpenStack. And this is all on the private end, on your own data center. And on the public cloud, we have things like Amazon Web Services, Microsoft Azure, Google Cloud Platform, and several others. So we've got a proliferation of these platforms that we can deploy to. And that's making things a little bit more interesting for IT operations. So I think it helps to just go over the term cloud real quick. NIST, the National Institute of Standards and Technology, which is part of the U.S. Department of Commerce, in 2010 came out with a set of guidelines for what is considered cloud computing. Now, before that, cloud computing the term cloud had been a little bit nebulous, and it even had been derided for being unclear and being thrown upon a number of products, and we would call it cloud washing. And it wasn't really clear what cloud was and what cloud wasn't. And then NIST came out with the definition of the term, which really does set a nice demarcation point between what is cloud computing and what came before it. So first, there's 3 types of cloud: public cloud, private cloud, and a hybrid cloud, which is where you use aspects of both or use components of both. We have 3 types of service: software as a service, platform as a service, infrastructure as a service, the latter of which is what we are mostly discussing in this CloudCenter discussion. And certainly there's more types of services nowadays. And then there's 5 characteristics for any cloud platform. And I think really here is where the differentiators are between cloud computing and how we've been doing, especially enterprise IT before. And number 1 is probably the most profound change in how we do operations in enterprise IT, and that's self-service. Traditionally, if you need a resource as a non-IT staff member, you would open up a ticket, and that ticket would get serviced by the IT staff. So if you needed a VM, you would open up a ticket. If you needed a new data store, NESXi or in vSphere, you would open up a ticket, and someone would go into the NetApp or to their storage array or whatever. And the problem with that, though, is it's not a very dynamic. It's not a very dynamic way to consume resources. It takes a lot of planning ahead of time and a lot of wait because it could take 2 hours for a ticket to get serviced. It could take 2 days. The same request may take 2 hours one day and take 2 weeks the next day. So being able to self-provision. So if you're a developer and you go in and you say, I need a VM, and you just go to the cloud platform interface and say, I need a VM, and then it gets instantiated within a minute or so. So that's a big difference in how we consume IT. The second is APIs. So in order for us to be able to do these kind of automations and orchestrations where one component from one vendor is talking to a different component from a different vendor, we need some way to reliably do the configuration. And that's generally done these days through a REST-style API. Before that, we had things like scripts with screen scraping, and it wasn't really reliable, or SNMP, which had some problems of its own. So REST APIs have come out to be this universal way to configure devices. So that's true for Amazon, for Azure, for Cisco devices. Of course, CloudCenter has a REST-based API that you can interact with. So it really is the glue that binds all of this new data center technology together. And if you don't have an API, then you're not really a cloud platform. The next is pooled resources, also known as multi-tenancy. Now, if you're Amazon, for example, then you're going to have tens of thousands of different tenants, and you want to make sure that they can't see what each other is doing or interfere with each other either accidentally or maliciously. In the enterprise, it's a little bit different because we're typically not dealing with tenants like Coke and Pepsi. We're dealing with John and Jane. And what we can use multi-tenancy for is to shrink the blast radius in case John's project makes a mistake and makes a misconfiguration. Rather than taking down an entire platform, it'll just take down that tenant and not affect Jane. So multi-tenancy is useful for that, to shrink the failure domain, so to speak. Elastic is the fourth characteristic. That means I can spin up and spin down resources very quickly. So not only adding resources, but also terminating them. So we're built to be a very dynamic environment, so things get created and destroyed quickly. And then finally, metered service, which is also something that we haven't really had much in IT, in enterprise IT at least. The ability to say this department or this project or this sales initiative, et cetera, has this exact dollar amount cost in terms of compute, network, storage, et cetera. So to be able to do chargeback is a fundamental shift in the way that we fund IT. IT has traditionally been a kind of a cost center, and organizations would, they would go in and say, hey, we're doing this new sales initiative, and I need you to spin up all these VMs. And a lot of times the IT department has to eat that cost and then ask for more money, and then everyone's mad that they're asking for money and sees it as a cost center rather than a business unit. So metered service is certainly important. And these are all aspects that CloudCenter provide. CloudCenter is self-service. You can grant access for non-IT staff, developers to deploy applications. It's got APIs, a REST-based API that you can use to trigger deployments and so forth through that way. It's multi-tenant. You can use one tenant or multiple tenants. It's certainly elastic because you can consume and destroy resources quickly. And then it's metered because we're going to be able to track application costs, not only in vCenter, but also in Amazon. And we do it on a per application basis rather than a per VM basis. So why, and one of the things that CloudCenter is meant to do is meant to make public clouds more consumable by enterprise IT. So why would an enterprise IT organization want to consume the public cloud? Traditionally, they've been into the private cloud, into their own data center. And so there's a couple of reasons why. So in the private cloud, of course, our operational expenditure is very low. So once I've paid for all the gear, then I can run that gear for a relatively low amount of money. Now CapEx is high, so I have to buy the servers, I have to buy the network gear, I have to buy the storage gear, I have to buy the compute gear, and that expenditure is typically quite high. But the more resources I can run on that given equipment, the more usage I get out of it, the more valuable it is. So if I buy a bunch of servers and networking gear and storage gear and I run one VM, that's a very expensive VM. But if I run 10,000 VMs on it, the price goes very low. And I can amortize that cost over 3 years typically, or something like that. And I can get a very efficient usage of equipment. And in fact, it's usually much more cost effective for consistent workloads. So that means a workload that has a virtual machine that I need to run for 3 years or 4 years or 5 years. A workload that is consistent, it's not elastic, it's not scaling in and scaling out. I have a consistent utilization need, or it's growing at a predictable rate. I'm pretty much going to get, I'm almost always going to get a much better value return on investment. I'm going to get it's going to be much more cost effective if I do a private cloud, if I buy the gear. So if I buy the gear, it's kind of like renting a car versus buying a car. So if I just need a car because I'm hanging out, I'm spending the week in Toledo on business, I'm not going to go to Toledo, buy a car for a week and then sell it back and try to sell it. That's too much hassle. I'll just rent. But if you try to rent a car for a year or for 2 years, it's really more like a lease, but that model doesn't work there. So it's typically far more cost effective to do consistent workloads in the private cloud. Plus you have data sovereignty issues. There's some legal issues. HIPAA compliance, PCI compliance, what can I put out into public cloud versus what do I need to keep private? And it varies from region to region and country to country. And if I run my own gear, it's a little bit of a two-edged sword here, but if I run my own gear, I'm responsible for the SLAs, for the service level agreements, versus being dependent upon Amazon or Azure. And if they have an outage, then I'm at their mercy. Versus if I have an outage, it's not going to be good, but at least I have control over the outcome, or as much as possible. On the public cloud, on the other hand, there's some advantages there. One is CapEx is pretty much zero. I don't have to spend any money outright or very little money to run workloads in the private cloud. However, operational expenditures can be high on the long term. So it's typically more cost effective for bursting workloads. So let's say I'm running a Super Bowl ad and I know I'm going to get a lot of traffic. It's going to be seen by millions and millions of viewers. They're all going to go after that commercial, type in my URL, and then my normal servers are going to get slammed. So I rent some VMs on Amazon or Azure and run that workload to absorb that particular burst. And then once that has petered off, then I can kill those VMs. Because VMware does not really cost per month unless you amortize out the cost or whatever. If I start a VM on VMware, as long as I have capacity, it doesn't really cost me anything extra OpEx-wise to run one VM versus two VMs. On Amazon, it's going to cost me twice as much to run two VMs perpetually as it does to run one VM if they're the same size. So Amazon's charging you per hour for that VM to be running. So if you have a bursting workload, or if you have a couple times a year, a couple times a month, you need extended capacity, then the public cloud is almost always better for that. And for the most part, they're infinite. There are some cases where you can run into a region might run out of a certain type of instance or a certain type of ability to provide a service. But most companies aren't going to run into that. They're not going to see Amazon or Azure as being a finite resource. And it's on demand. There's no lead time. If I have a project and it has a very short lead time, you know what? Maybe I'll start out in the public cloud and then migrate to a private cloud later because I just need to get everything up and running right now. Another shift we're seeing in IT is manual to automated. We're automating more and more of the processes that we're doing in IT, from manual OS, manual patches, manual OS config, manual application install, manual application configuration. A name for this might be Mode 1 operations. So you probably heard of Cisco using this term in Gartner, Mode 1 and Mode 2. So Mode 2 would be, instead of doing manual installations of an operating system or customizing an OVA, we use an immutable OS image because we really don't care that much anymore about the OS. We're going to cookie cutter, stamp these things out. We're doing automated patch remediation, automated OS configuration with tools like Puppet and Chef, automated application installation, and automated application configuration. Again, with tools like Puppet and Chef and other scripting tools, there's an ability there to, it works out a lot better in terms of operations if I can automate everything so that if a resource gets damaged or destroyed, I can recreate it, and I'm much more flexible in my operations that way. And automation brings us a consistency that we can't get, and a consistency and a speed that we can't get by doing things by hand. Certainly from a public, on the public cloud, we have the self-service issue is how do we go from a system where we're using tickets to a self-service system. Sometimes we need to make sure that we have the proper portals and APIs available. And certainly automation is going to be required for this new world. And migration applications are often tooled for a specific platform. So if you want to migrate from Amazon to vSphere or vice versa, then your deployment processes are going to need to change. Cost control, persistent VMs are very costly. When we talk again, as we talked about public cloud or private cloud rather, when you start up a VM in a private cloud, you've already paid for the equipment. So it only costs you just a little bit extra electricity to run a VM versus not running a VM. So it doesn't really cost you much to keep it running it perpetually, especially if it's not doing anything. It's not consuming up CPU resources. not using much memory, not much disk I/O. It can just kind of sit there quietly and not bother anyone, and you won't really have to worry about leaving it on. But of course, even if it's a very quiet VM, if you leave it on running on Amazon or on any of the public cloud providers, they charge per hour, per 20 minutes, or whatever their intervals are. But they're going to be charging you for for all the time that it's up and running. So it's a very different style of mentality. And again, we've been hit by this before at Lumos, where we've accidentally left VMs running for weeks when they didn't need to be. We had to pay for it. And so VM sprawl can be extremely costly. And then, of course, how to leverage multiple clouds. There's a lot of advantages to running. As we discussed, there's a lot of advantages between public and private clouds. Some may be more beneficial than the others. And it's good to have the flexibility to move between them and to move between the different cloud providers. Maybe one quarter that Amazon is giving you the best price, and the next quarter Azure drops their price because they want your business. So a lot of that cost savings can get eaten up by retooling the application for a specific platform. Whereas it would be nice to have a single platform that could deploy onto all of these public and private cloud providers. So to recap the problems, some of the challenges that IT organizations are facing is one is a proliferation of platforms. So how can companies leverage the plethora of platforms that are out there now? We've got public cloud, private cloud, and as we've discussed, they both have their advantages and they both have their situations where they may be more beneficial than the other. So a lot of IT organizations want to have the ability to use both, but the tooling isn't quite there yet. A need for application management modernization, an automation platform so that applications can be deployed rapidly and updated rapidly, as well as migrated from one platform to another. And then adapting to public cloud usage. Public cloud is used a little bit differently. It's certainly charged differently. That's a big issue that we have is cost control. Again, the Amazon surprise or the surprise bill at the end of the month, as well as sizing. How do you size? All the cloud providers charge different amounts for the various sizes and types of VMs. So it's critical to determine, especially from a cost perspective, which size of virtual machine is best for a given application.